Hello, happy people. This will be your last video for this fourth week of virtual learning here in Algebra 2. We have talked about exponential growth and we talked about compound interest and continually compounding interest as part of growth. And now we're going to finish it off with decay. So here's a reminder about exponential equations and what our equation for decay will be. I'm going to pause for a second so you can pause the video and take notes in your notebook. All right, remember, just like there's an equation for lines, y equals mx plus b, and the equation for quadratics, which is y equals ax squared plus bx plus c. There's an equation for exponential equations, which are y equals ab to the x, or in this case, we're using t for time. When we had growth, we were adding a rate to 100. Now that we have decay, so we're going to be going down, we're going to subtract a rate from 100% or have 1 minus r. And so instead of y equals a times 1 plus r to the t, we are going to have y equals a times 1 minus r to the t. So here's the example we're going to do. So just like when we started with growth, we're going to write an equation, and then we're going to actually use that equation to solve for something. We're going to do the same thing today with decay. So I'm going to again pause so you can pause the video and write this example in your notebook, and then we'll go over it. All right, so decay is going to be represented by populations and something called depreciation. So as soon as you drive anything off a lot, a car, a truck, a boat, anything, the value of it depreciates, meaning it's no longer worth the value of what you just bought it for. So we're looking at a motorcycle here. If we bought your motorcycle for $25,000, it depreciates at a rate of 20% per year. This is a high depreciation rate. But that's actually true of any vehicle you buy until it gets to a certain age. And then if you took care of it for 25 years, then it starts to become a classic. Then it'll start to gain value again. But as you buy any of these vehicles, they actually start to go down. So our example said you buy a motorcycle for $25,000 and it depreciates at a rate of 20% per year. So our first thing is to write an equation. Remember, the equation we just got is y is going to be equal to a times 1 minus r to the t. So in this case, our original amount that we paid for our motorcycle was $25,000. And the rate that it goes down would be 20% per year, or 0.20. And so we're just going to fill those things in and simplify to write our equation. So we're going to have y equals 25,000 times 1 minus 0.20 to the t. And if we simplify, we'll have y equals 25,000 times 0.80 to the t. Now remember, you cannot distribute that 25,000 to multiply it by the 0.8 because we are taking it to the t power, and the order of operations states that we do exponents first. So this is actually our answer for write an equation, which is what the first bullet said to do. All right, so we just got the equation y equals 25,000 times 0.80 to the t. And the next bullet says, how long would it take for the motorcycle to depreciate to a value of 25,000? So just like when we had growth, you're going to have some equations where you're just going to, you're going to know your time. So you're just going to plug it in and plug that into a calculator. Or in this case, we know what our y is, what we end with. We end with $2,500 for our value of a motorcycle, and we want to know how much time that actually took. So this is an equation, since we're trying to solve for an exponent, that we can use logs to solve. And remember, when we're trying to use logs to solve and we're going to put a log on both sides, the first thing we want to do is get the power all alone. And in this case, our power is 0.080 to the t. So to get that alone, the first thing I'm going to do is divide by 25,000 on each side. And if I do that, 2,500 divided by 25,000 is 1/10, or 0.1 to the t. And now I'm ready to take the log of each side. Which allows me to bring that t down using my expanding rule. So I'll get the log of 0.1 equals t times the log of 0.8. And so I'm going to divide my log over. So I'll have the log of 0.1 divided by the log of 0.8. Should give me my time. So this is something you just have to plug into your calculator. Be careful of your parentheses. Make sure you close after the 0.1 for the log of 0.1 and after the 8 for log of 0.8. And if you put that in your calculator, you should get 10.32. So it takes 10.32 years to depreciate to $2,500. All right, so that's using our decay formula to solve a problem for time. You will have problems where you just have to plug in the time and plug that into your calculator and get an answer, but the harder problems will have you solving for t. So I hope you are all happy, I hope you are all healthy, and I hope you all have a great day.